Yes, students, we are discussing today the structures of interhalogen compounds, the structures, and that we have to describe as per VSEPR theory. Let me focus my attention on XY kind of such linear interhalogen compounds. In true sense, there remains a lone pair. Here there is remains a one lone pair. Here it remains a second lone pair. Here it remains a third lone pair, and it is a fourth hybrid orbital where the bond formation. But hybridization we are not discussing. We want to discuss interhalogen compounds. Yes, the type of interhalogen compounds is XY. X is a central halogen and Y is a peripheral. Actually, only one halogen remain present there. I want to know the answer from you. In general, what is this is our first point. First point is central atom is X. Its electronic configuration. Yes, students, I want answer from you. What is the outermost electronic configuration of such elements? There remains any noble gas. Maybe helium, maybe neon, maybe argon, maybe krypton, maybe xenon, such noble gases. After that, outermost electronic configuration of halogens. How can I write? Take any halogen, no, say fluorine. What is the electronic configuration of fluorine?
1s2.
Yes, 1s2 means it's a helium. It's a noble gas that I represent here. Afterwards.
2s2.
Yes.
2p6.
Again.
3s2 3p5.
No. 9 electrons are there only. Count the number of electrons and then tell me. What is the mistake?
1s2, 2s2, 2p5.
Yes, it is the outermost electronic configuration that I am representing here in general. This N means 2. Here S I represented. So NS2, help me now. NS2, N means outermost shell. 2. This P also I have to represent here. P, 5. This is the outermost electronic configuration for any atom. Let it be the chlorine, let it be the bromine, let it be the iodine. Yes, are you following what I'm saying?
Yes, sir.
Second point, total outer electrons. How many outer electrons are present? Here, it's outermost orbitals. How many electrons are present?
7.
Yes, right, 7. Third point, let me see who wants to enter. Shruti. Total number of bonds. Number of bonds. Now here only halogens are there. Those single bonds only will be there. Single bonds. In case of oxyhaloacids or oxyacids of halogen, double bonds were there with oxygen. So steric number was somewhat little complicated. Instead of single bond, I have to consider double bond. Here whichever atoms are there, they are forming single bonds. Number of bonds. Of course, those are single bonds. How many will be there? Those number of bonds is equal to number of peripheral atoms. How many peripheral atoms are there? How many surrounding atoms are there to this X? X is a central atom. Other than central atom, how many atoms are there? Those many bonds will be there of X.
1.
1. So out of these 7, one electron is involved in a single bond formation. Then we have to answer number of lone pairs is equal to remaining electrons will be in terms of the lone pairs. Pairing will be there. Total there were 7. Out of that 1 is used divided by 2 because pair we want therefore 6 electrons will be there. So how many pairs will be there?
3.
7 minus 1 divided by 2. What's the answer?
3.
Yes, 3. Now fifth point, steric number which is equal to bond pairs plus lone pairs. Here double bonds are not there, single bonds only are there, which is equal to how many bond pairs are there? 1. How many lone pairs are there? 3. So what's the steric number?
4.
Yes, 4. Now last point is about the structure. So because of steric number 4, what will be the structure?
Tetrahedral.
4 means what that 4 indicates? Right, tetrahedral. 4 bonds will be there. 4 species will be there, not necessarily 4 bonds. 4 species will be there. Actually, how many bonds are there? Only 1. How many lone pairs are there? 3. If tetrahedral, then how can I represent that structure? A chlorine I need to consider, which is with 1 bond. With whom? Say fluorine. Or in general, if I am considering X, it is forming bond with whom? Y. And remaining lone pairs are there. How can I represent those lone pairs? If I represent here on the X, one lone pair, second lone pair, and third lone pair. Overall structure is tetrahedral. Means tetrahedral how arrangement remains? The four species, out of that three where here lone pair is there. Here lone pair is present. Here lone pair is present. So from structure point of view, it is tetrahedral. But if you see the shape of the molecule, answer for my question, how is the shape? How are the atoms aligned? Don't consider lone pair, only the atoms, how are they arranged? What will you say for such kind of arrangement? Which kind of shape it will be for that CLF?
Linear.
Linear.
Right, linear. Brilliant answer. Linear. Over. It's a explanation of XY kind of any interhalogen compound. It can be CLF. It can be BRF. It can be IF. Yes. Is that first type of interhalogen clear to you?
Yes.
Yes, sir.
Yes, sir.
Yes. Now let us come to the second type of interhalogen compound. And what is the second type? X central halogen, Y peripheral hydrogen, and how many are there? Three. Our points are same. The first point. Yes, what's the first point? Central atom. What is it? X. What is the first point? Electronic configuration. Keep in mind, for next example I will ask electronic configuration. Electronic configuration general. Suppose if particularly asked, no, then you can take there Cl. You can write the electronic configuration of Cl, but I am writing here general electronic configuration. That's a one noble gas will be there, followed by NS2NP5. If chlorine would have been there, then here you will write electronic configuration of, in spite of X, you will write chlorine. And which noble gas will you consider? Neon. And then NS2 NP5. Likewise you will write. Depends which molecule you are considering. I am talking here general XY3 molecule, so I am considering any general noble gas. Second point,
Number of
total.
electrons.
Yes, total outermost electrons. In, yes, how many are there? Yes, here outermost, how many electrons are there? In any halogen, how many they remain?
7.
12.
7.
7. Okay.
7.
7. Yes, right. What's the third point?
Number of bonds.
Yes, now number of bonds, or you can say bond pairs, is equal to number of atoms surrounding. How many are they? Yes,
3.
3. Now, fourth point. Yes,
Lone
what's the
pair.
fourth point?
Lone pairs.
Number of lone pairs. How can we find that? See the total number of electrons. How many are they? 7. Minus, see how many electrons are involved in the bond formation? 3. Divided by 2. What's the answer?
2.
True.
Right, 2. Now, what should be my next point?
Structure.
Steric.
Yes, steric number. The steric number is a summation of number of bond pairs plus lone pairs. Yes. How many bond pairs are there? 3. How many lone pairs are there? 2. So what is the summation? 5. I need your help
5.
now. If 5 is a steric number, then next point is structure. How will be the structure? If the steric number is 5, then structure. If it is 4, then you say tetrahedral. Likewise, I am asking if it is a 5, then what should be there?
Trigonal bipyramid.
Exactly. Structure will be TBP, trigonal bipyramidal. I have to represent that structure. Means I have to represent the 5 sides there. Means I have to consider triangle. Let me consider the triangle 1. Just I am considering one triangle. And one point will be upside. Actually, it should come upside down. Or separately, if I represent, you will understand it neatly. It's a one bond, or maybe the lone pair. What is there that we have to find out? Similarly, there will be what the other bond, which is coming from there only, but because of that structure, time being what I do, I don't represent that the complete session. Only this much I represent. Total how many sites are there? It is a position number 1, first site. It's a position number 2, position number 3, position number 4, and position number 5. These are steric numbers. Out of these 5 positions, at few positions there will be lone pairs, and at remaining positions there will be bond pairs. Answer for my question: how many lone pairs I do have, and how many bond pairs I do have now in this structure? Steric number that you have found 5, how many lone pairs were there?
2.
2.
Yes, two lone pairs. And how many bond pairs?
3.
3.
Three. Now let us arrange first lone pairs. Total 5 sites are there. What do you think? These lone pairs will occupy which position? Where will they go? Which position will they occupy? What is your guess?
1, 5.
1 5.
Yes. Very good. One answer is position number 1 and position number 5. Any other answer?
4, 2 or 2, 3.
Yes. Other possibility is there that lone pair can occupy 2 4 position, or lone pair can occupy 2 3 position, or lone pair can occupy, yes, help me.
4, 3.
Yes, 3 4 position or 4 3 position. These are the possibilities. This total 4 possibilities are there. Out of that, these 3 possibilities are of one category. These 3. Answer for my question. These positions, position number 2, position number 3, and position number 4, are called as which kind of positions? Labeling equatorial or axial?
X.
No, those are equatorial positions. Means what I want to say, 1 and 5, 1 and 5, these are axial positions. Is it clear? Whatever I said terms.
Yes, sir.
Yes, sir.
Now question is about these lone pairs. Where should these lone pairs arrange? First I consider your first answer. Lone pair occupies this 1 and 5 position. So I represent this lone pair, one lone pair, and second lone pair here. From repulsion point of view, between these lone pairs, what is the angle? What is the angle between those two lone pairs? Yes, what's the angle in between these two lone pairs?
180.
180.
Right, that angle is 180 degree. Means they are away from each other. Their repulsion is less. With that logic, this answer 1 and 5 is correct. But one more logic is there, that you have to think about how many 90-degree repulsions are there by that lone pair. I am asking now, how many 90-degree repulsions are there? How many bonds who are there separated by 90 degree compared to this lone pair? Consider any lone pair. Answer for my question. This lone pair makes how much angle to position number 2? I am
90.
asking about this angle.
90.
Right, 90 degree. Here all where angles are what? 90 degree. So how many 90-degree repulsions are there? This bond will repel this lone pair. This bond also will repel this lone pair. This bond also will repel this lone pair. Reverse also is true. Lone pair will repel the bond. So how many 90-degree repulsions are there? 90-degree repulsion is equal to 3. Are you following what I'm saying?
Yes, sir.
We are considering lone pair here. This lone pair makes 90-degree angle to position number 2, position number 3, position number 4. Because of that, I said here 90 repulsions are 3. If I consider lone pair as in this position, these positions, means if I consider lone pair at position number 2, I remove that lone pair now. Previous lone pair I remove. And if I consider lone pair here, just wait, I could not remove that. Let it be as it is. If I consider lone pair here, now I am representing by the blue color. One of the lone pair. Then this lone pair, which lone pair? Blue colored lone pair makes how many 90-degree separations? How many 90-degree repulsions? This blue colored lone pair. When lone pair remains here, then that red color lone pairs are not there. Yes, could you able to understand what I'm saying? Is my question clear?
Not clear, sir.
Okay, fine. Pay attention. Could you able to understand the structure now upside given?
Yes, sir.
Somewhere eraser is not working. Okay, I am asking about this structure. These green lone pairs are there, or these equatorial positions are this equatorial position. This equatorial position makes how many 90-degree angles? Approximately here, whatever angle shown, don't worry about that. It is 190 degree, second 90 degree. And what is the bond angle between lone pair and this bond pair? Yes, help me. What is this bond angle? This bond angle. Bond angle between this lone pair and this bond pair. How much angle is there? How much angle between the blades of the fan? Approximately, I'm not talking about this exact calculation. The blades of the fan,
120.
how much angle? Yes?
120.
120 degree. My question is regarding 90-degree repulsions. How many 90-degree repulsions will be there? This likewise, this one. So how many are there 90 repulsions? It's a 190 repulsion. Second 90 repulsion. How many are there?
2.
2. Yes. Means what? If you consider lone pair at equatorial position, you will get 2 90-degree repulsions. If you consider lone pair at equatorial axial position, there will be 3 90-degree repulsions. Means what? whatever the trigonal bipyramidal structure we are considering, it's a triangle, up bond, down bond, position number 1, 2, 3, 4, these are equatorial positions, and position number 1 and position number 5, these are axial position. If I consider example the lone pair in axial position, then it causes how many 90-degree repulsion? If axial, then how many 90-degree repulsion?
3.
3. If I consider the lone pair at equatorial position, means say this position, how many 90-degree repulsions are there?
2.
2. The rule is minimum 90-degree repulsion, that is a stable situation. Minimum 90-degree. So where are minimum, where are less 90-degree repulsion? If lone pair remains at equatorial position. Therefore, this structure where lone pair remains at equatorial position is correct. At first, what you have answered, position number 1 and 5, it seems to be the correct on the ground of lone pair repulsion. But who is the dominating factor here? 90-degree repulsion. 90-degree repulsions are less in case of this equatorial position. So lone pair will occupy equatorial position. Answer for my question, how many lone pairs I am with?
3.
Lone pairs.
2. 2.
2 lone pairs. See here, 2. So this lone pair and that lone pair, they will repel these bond pairs. One more bond pair I need to show here that I represent. It is the bond pair. So if I consider X, Y, 3, then X will be at center. Y will be at position number 1, at position number 3, and at position number 5. And here other where lone pairs are there. So structure is trigonal bipyramidal, but distortion is there. Because of that lone pair, which lone pairs? These lone pairs. Here electrons are there, this lone pair. Because of this lone pair, the repulsion will be there to this bond pair. Repulsion will be there to this bond pair. And because of that, whatever this angle you expect to be previously 90-degree, but it is less than that. And exactly if I have to say, it is 88-degree. It is a structure of ClF3. 88-degree particularly for ClF3. Or you can say in general, less than 90-degree, then it is the structure for XY3 kind of interhalogen. Is that point clear? If it is not, then bring it to my notice. Where is the problem?
Yes, sir. Clear.
Yes, sir.
Sir.
Yes. Now let me consider other kind of the halogen, that's XY5. I hope that you will help me to answer that here only. These points only I consider. The first point, as usual, what is the first point? It is an electronic configuration. That is NS2, NP5, same will be there. Outermost electron, as usual, 7 will be there. Number of bond pairs, yes, I am considering XY5. How many bond pairs are there?
5.
Yes, here will be the 5. How many lone pairs will be there?
1.
Right, 1. Yes, Ganesh and Rishikesh, are you following?
Yes, sir.
Okay. So what is the steric number?
6.
Right, it is 6. What is structure? If 6, then structure?
Octahedral.
Right, structure will be octahedral. Octahedral means how many bonds will be there? How many bonds or how many steric factors will be there? Steric spaces will be there? 6. So how I have to represent the octahedral? About that, let me have the discussion. I represent the octahedral structure. Consider square. Actually, just imagine atoms corners are there, and then you have to consider one upper bond. Similarly, you have to consider one lower bond. But I have to decrease the length of that, the lower bond. Yes. Now total number of positions. How many? Position number 1, position number 2, position number 3, position number 4, position number 5, position number 6. Now I want to know the answer from you. What do you think? All these positions 1 to 6, are they equivalent or non-equivalent? Equivalent means are they uniform, are they same or not uniform?
All are equivalent.
Brilliant, brilliant. All are same. Let me consider position number 1 or position number 2 or position number 3 or position number 4 or position number 5 or position number 6 are equivalent, because every bond or every line joining will make here 90-degree angle, here with position number 5 90-degree angle, with position number 3 90-degree angle, with position number 4 90-degree angle. So 4 times 90-degree separation with any position. Let me consider. If I consider position number 2, then with position number 1 it will make 90-degree angle. With position number 3, it will make 90-degree angle. With position number 5, it will make 90-degree angle. With position number 6, it will make 90-degree angle. So your answer is right. All positions are equivalent. If all positions are equivalent, then what will be there? Lone pair. There's only one lone pair. That lone pair will occupy which position? That lone pair will occupy which position? Out of those 6 positions, where should that one lone pair go? Because we found there, no, one lone pair is there and 5 bond pairs are there. You said all positions are equivalent. Means position number 1 to 6 all are equivalent. Then where shall I represent that lone pair? At position number 1, at position number 2, 3, 4, 5, or at 6? See, if question not clear, I'll repeat. Let me know. Is the question clear?
Yes, sir.
Yes, sir.
Yes, sir.
What's the answer? We already concluded there is one lone pair. There are 5 bond pair. Now my concern is about this lone pair. Where shall I represent that lone pair? At which position? Just guess. Any particular position or any position?
Any position.
Right, any position, anywhere I can place that. May it be the position number 1, or may it be the position number 2 or 3 or 4 or 5 or 6. I represent that lone pair at this position number, say 1. Anywhere you can represent position number 1. So other where bond pairs will be there. It means at position number 2, there will be the one halogen, say it's a Y. At position number 3, there will be the halogen Y. At position number 4 will be the halogen, say Y. At position number 5 there will be halogen Y. At position number 6 also will be the Y. And at center there will be the X. It is a structure. What is the structure? Distorted octahedral. Because of this lone pair, these bonds, bond with position number 5, bond with position number 2, bond with position number 3, bond with position number 6, will experience burden, will experience tension. So they will get some press. So if you have to calculate this angle between upper bond and this will be more than 90-degree. And if you see the angle between this bond pair and this plane, it will be less than 90-degree. It indicates the effect of this lone pair. Lone pair is causing the repulsion. It's an explanation on the basis of VSEPR theory. Is it clear?
Yes, sir.
Yes, sir.
Yes. Now the last structure, that's a XY7. Now help me. As usual, point is same. NS2 NP5 automated configuration. Total electrons are 7. So number of bond pairs, tell me now here. This one.
7,
7. Number of lone pairs.
0,
Right. Steric number.
7,
Structure. Here it is a TBP. Here octahedral means square bipyramidal. SBP or octahedral. Likewise, here for 7.
Octahedral.
No. Octahedral already completed. Octahedral means 6 bonds will be there. Here 7 bonds are there.
pentagonal bipyramid,
Yes, pentagonal bipyramidal. Here trigonal, here square, and here pentagonal bipyramidal. That will be the structure for that XY7 molecule. If I have to represent that structure, then I need to consider one pentagon. I need to consider one bond upside. Pentagon is a base. Let me rotate that pentagon so that it will be easy for you to understand. Yes. Consider the symmetric pentagon. Now I need to consider one bond upside. By the way, one more bond downside. It is a pentagonal bipyramidal structure, and there is no ambiguity that there is no lone pair. So we need to represent all the bonds only. So wherever the sites are there, total how many sites are there? Yes, help me. How many sites are there? The position number 1 is first site. 2, 3, 4, 5, 6. Like 7 sites are there. How many bonds are there?
7.
Yes, 7 bonds are there, and I represent those 7 bonds. It's a bond at position number 2. Similarly, bond at position number 3, bond at position number 4, bond at position number 5, bond at position number 6. Yes, now I want answer from you. What will be the bond angle between the position number 1 and position number 2? This bond angle. Pentagon 2, 3, 4, 5, 6 is a one plane. One is upside and 7 position is downside. Are you understanding what I am asking?
Yes, sir.
What's the bond angle? Here see, the bond angle already present. IF7 molecule they have considered. I am talking about XY7. What is the bond angle? Position number 1 and position number 2.
90 degree.
Right, 90 degree, other way 90 degree, all way 90 degree. But what will the bond angle in position number 2 and position number 3? For that, what will you do? 360 degree is our circle. Position number 2, position number 3, position number 4, position number 5, position number 6. Likewise, will complete. So the structure circle means 360 degree divided by, it will divide in how many parts? 5 parts, because pentagon is there, no? So 360 divided by 5, what's the answer?
70.71, 72.
72 degree. So this bond angle is 72 degree. Structure is pentagonal bipyramidal. Example is IF7. So students, we have discussed today the structure of XY kind of the interhalogen. Structure is tetrahedral and shape is linear. Is it clear?
Yes, sir.
Yes, sir.
If you consider the second type of the interhalogen XY3, structure is trigonal bipyramidal but shape is T shape. This T, you have to consider is 1, 2 and this T. Likewise, we are representing horizontal T. Generally, we draw the T capital likewise, no? So only we have to rotate that T so that T will come in this way. It's a T shape. Is it clear?
Yes, sir.
Yes, sir.
One more reply I want. It's a third category of the molecule. XY5. What is the geometry? Octahedral. But structure is square pyramidal. Sorry. Shape is square pyramidal. Here lone pair is not one position. Maybe upper position. I have shown upper side. Here they have shown downside the lone pair. And square pyramid, how these equatorial sides will form square and upside is apex. So it is a pyramid, square pyramid. Is the structure clear?
Yes, sir.
The last structure,
Yes, sir.
XY7. What is the structure?
Pentagonal bipyramidal.
Pentagonal bipyramidal. What is the shape? Same, because there is a no lone pair. Pentagonal bipyramidal only. Here see, structure is tetrahedral, shape is linear. Structure is TBP, shape is T shape. Structure is octahedral, shape is square pyramid. Shape means atoms we have to consider. Structure means lone pair also we have to consider. So here by no means one can say CLF means tetrahedral. Shape point of view it is the linear only. But structure point of view when we consider lone pair it will be tetrahedral. Shape point of view it is a T shape. If we consider XY3 as atoms only. But when we consider lone pairs the structure is trigonal bipyramidal. The shape is square pyramidal, but from structure point of view, when we consider this lone pair, it will be octahedral. Here, structure and shape both are same. That's a pentagonal bipyramidal. Yes, students, are the points clear?
Yes, sir.
Yes, sir.
Students, it was the point was left. So syllabus from my side is what covered majority portion. Only 2 points are left which are kept for your preparation. First point, superconductivity, and second is non-aqueous solvents. Otherwise, all aspects of inorganic chemistry and analytical chemistry we have covered. Many students have not completed assignments. See, afterwards, every teacher will complete the syllabus, then the experimentation, practically will not find time. So complete assignments in time. So I've attempt to complete today only your that's a work, but it will take too much to at late night or tomorrow morning. Certainly you will get today's lecture as well as previous lecture. So prepare the notes of that and complete the assignments. By the same time, pay attention towards the experimentation. So students, shall we stop now?
Yes, sir.
Okay, sir.
Yes, I'm going to stop the record.